Let's look at what we have today. 3 marbles are chosen at random without replacement from a bag containing 4 red marbles and 6 yellow marbles. Find the probability that A, 2 red marbles are chosen, B, at least 2 yellow marbles are chosen. First, before we start, I want us to note something, and that is the fact that the clause without replacement is very important to our solution. That's number one. And number two, that this kind of problem is best solved with a tree diagram. I've sketched the tree diagram here to save time, but I'll explain how it works, and then we'll be able to get the individual probabilities of each of the branches of the tree diagram. So let's start. Now there are 4 red marbles. I've chosen to use the letter R for red. So we have red 4. Yellow marbles, we choose the letter Y. And then there are 6. So there's a total of 10 marbles in the bag. Now, this is how the tree diagram goes. Okay, something else I need to explain. 3 marbles are chosen at random. Now, what this is saying is that a marble is chosen per time 3 different times. So there are 3 picks. Now let's go back to the tree diagram. The first pick could either be a red marble or a yellow marble. So it branches into a red or a yellow. The second pick, each of the branches will branch into red and yellow. So this will branch into red and yellow. This branches to red or yellow. And then in the third pick, each branch again will branch to red and yellow. So this branches red or yellow, and so on and so forth. Now, the outcomes, or what I may like to call the fruit of the tree, will be, here will be just following the branches, red, red, red. So we have red, red, red. Here, red, red, and yellow. So we have red, red, yellow. Here we have red, yellow, red. Here we have red, yellow, yellow. Here we have yellow, red, red. Here we have yellow, red, yellow. Here we have yellow, yellow, red. And here we have yellow, yellow, yellow. 1, 2, 3, 4, 5, 6, 7, 8 outcomes. And that's because we are dealing with two marbles, red and yellow, and we had to pick it 3 times. So we have 2 raised to power 3, that's 8. Number of trials, then number of possible outcomes. Now we want to get the individual probabilities for each of the branches. Pay very close attention, because this is where a lot of students get confused. We've already seen that there are a total of 10 marbles, 4 are red. So in the first pick, the probability of picking a red marble is 4 out of 10. The probability of picking a yellow marble is 6 out of 10. For the second pick, if a red marble is picked again, remember, without replacement, the first red was not replaced. So there are 3 marbles in the bag now, and there are 9 balls altogether. So we have 3 out of 9. Now let's look at this branch. You picked a red first here. You have not picked a yellow yet. So there are still 6 yellow balls, but there are 9 balls in the bag because you've not replaced this one. Now, here you picked a yellow ball first. This second time you're picking a red ball, meaning you didn't touch a red ball, so there are still 4 balls, but it didn't replace this yellow. So there are 9 balls in the bag. Now you're picking a yellow. You have picked a yellow, you didn't replace it. So it's short 1. To pick a second yellow, that means there will be 5 yellow balls here. And then because there's 1 short, there are 9 balls in the bag. We move to the third pick. You picked a red, you didn't replace, you picked another red, it did not replace. So there are how many red balls now? 2. Because you picked 2 out of the 4. 2 are remaining. So for you to pick a third, the probability will be 2 out of, you have 2 red balls have been picked out without replacement. So there are 8 balls in the bag now. Now look at this one. You picked a red, you didn't replace, picked a red, you didn't replace, but you have not picked a yellow ball yet. So there are still 6 yellow balls, and yet there are 8 balls because you picked 2 red out. Now we come to this branch. You picked a red, didn't replace. You picked a yellow, it didn't replace. So there are 8 balls in the bag now. But this is the second time you are picking a red. So red balls have been short by 1. So this is 3. There are 8 balls in the bag. You picked a yellow after picking a red, didn't replace. Picked a yellow, it didn't replace. So 2 balls are out. You are picking a yellow again. Yellow is short by 1. So there are 5 yellow balls now, but a total of 8 balls in the bag. We come here. You picked yellow, you didn't replace. Red, you didn't replace. Now you're picking red again. It means red is short by 1. So there are 3. You didn't replace 2 balls, so there are 8 in the bag. Here, you picked a yellow, picked a red. Now you pick a yellow. You picked a yellow here, you didn't replace it, so it's short 1. There are 5 yellow balls now in the bag, and a total of 8. Now we come to this. You picked a yellow, you didn't replace 2 yellows. This is the first time you're picking a red. So there are yet 4 red balls, but there are a total of 8 balls in the bag. You picked a yellow, didn't replace. Picked another yellow, it didn't replace, meaning yellow is short by 2 out of 6, leaving us with 4. Now there are how many balls? 8 balls. Now let me show you a secret. When you add the branching of all of them, you should arrive at 1. Otherwise, there's something wrong. 3/9 plus 6/9 is 9/9. 4/9 plus 5/9 is 9/9, 1. 2/8 plus 6/8 is 8/8, 1, and so on. If question A says, find the probability that 2 red balls are chosen. Now be very careful. This question is deeper than it's asking on the surface. 2 red marbles are chosen. It didn't say first was red, second was red in a particular order. It's just say 2 red marbles are chosen. So the case is this, 2 red marbles. Another case is this, 2 red marbles. Another case is this, 2 red marbles. So there are 3 cases, 3 instances in which 2 red marbles are chosen. How do we find their probability? Again, let me say that this outcomes here means a red is chosen first, and a red is chosen second, and a red is chosen third. This outcome means a red is chosen first, a red is chosen second, and a red is chosen third. And in probability is multiplication. We'll take note of that. And then in this case, 2 red marbles are chosen means it's either this or this or this, or will be plus. I hope you've taken note of those 2 things. So let's look at this instance and find the result. Let's follow the individual probabilities of each branch. First is red, so we have 4/10 red, red again, 3/9, and then yellow, 6/8. Second case here, first is red, 4/10. Second is yellow, 6/9. Red, yellow, and then red again, 3/8. And then the third case involving two red marbles, we have first is yellow, 6/10. Second is red, 4/9. And then third is red, 3/8. Now, if we look at all of these fractions, you see 4/10, 6/9, you can say 6/9 here, 3/8. And then we have 4/10, 6/9, 3/8. You see, all of these fractions are actually the same. So if we can solve one out, then we have solved all of them. Let's solve one out. 4 here will be 1, here will be 2, 2 here will be 3, 3 here will be 1, here 3, 3 here 1, 3 here 1. So our answer here is 1/10. It means that this is also 1/10, and this is also 1/10. Now, the probability of choosing two red balls, let's put it like this. P of choosing two red will be either choosing red, red, yellow, or red, yellow, red, or yellow, red, red. And so this will be 1/10. All is plus 1/10 plus 1/10. And that gives us 3/10 for our answer. Now, we go to the next question, question B. It says, find the probability of choosing at least two yellow marbles. Again, look below the surface. At least two yellow marbles means there could be two yellow marbles or more than two yellow marbles. That case will be this, 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 and this. Let's clear this for space. So we again find the individual probabilities involving two yellow marbles or more than two yellow marbles. So let's look at this case. We have red, which is 4/10, yellow, 6/10, 6/9, and yellow again, 5/8. We come to this case, we have yellow first, 6/10, times red, 4/9, and yellow, 5/8. And then we come to this case, we have yellow, 6/10, yellow again, 5/9, and then red, 4/8. And then finally, we have 6/10, we have 5/9, and then we have 4/8. Again, if we look at all of these fractions, we see 6/10, we see 4/9, and then we see 5/8. In all of them, 6/10, 4/9, just like we have here, and then 5/8. 6/10, and all of them like that. So it means if we solve one out, we have got the result for all of them. So here, 1, 2, here we have 1, and then we have here 2, and here we have 1, and here 3, and here 1, and here 3. So the result there is 1/6. It means this is 1/6 also. This is 1/6, and this is 1 over 6. So the probability of choosing at least 2 yellow balls, let's write it like this: P of choosing greater than or equal to 2 yellow balls will be the probability of choosing red, yellow, and yellow plus probability of choosing yellow, red, and yellow plus the probability of choosing yellow, yellow, and red plus the probability of choosing yellow, yellow, and yellow. Now, each of them is 1 over 6, so we have 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6, giving us 4 over 6 or 2 over 3. Like, comment under the video, share, and follow for more. Thank you.